In the previous class, we did the definition and types of the polynomials, and we also did how to find the zeros of the polynomials. But today we will do how to plot the zeros of the polynomials on the graph. Okay, it means it is also called graphical representation of zeros. Okay, so I will explain you by giving a simple example. Suppose p of x is equals to x plus 2, and you know this is a linear polynomial. This is an example of linear polynomial. Okay, so how to find the zeros, that we did on the previous classes. So how to find zeros? You have to take this as 0. So x equals to minus 2 is the zeros of this polynomial. Okay, now I will teach you how to draw the graph of the zeros of the polynomial. Okay, so for this we have to take coordinate axes. It means you did this in class 8. See, I am making x axis and y axis. Okay, so this is one horizontal and this is a vertical. You know that this is x, this O, x dash, and y, O, y dash. Okay, so you know that in the right side of the x-axis, this is called x-axis and this is y-axis, and on that side it is positive. Okay, so this is 1, 2, 3, 4, 5 plus, and here I will take minus because opposite direction. Minus 1, minus 2, minus 3, minus 4, minus 5, and this is also same way upward in the direction of y-axis, means it is plus. Okay, 1, 2, 3, 4, 5, and this is downward, means minus of y. Minus 1, minus 2, minus 3, minus 4, minus 5. Now I will make a solution set. You know that we did in the class 8 or 9 that by making the solution box. Okay, same way I will do this. Okay, before this, one thing you have to know, here x axis, this x is called abscissa. No, in the coordinate geometry this is abscissa, means x axis, and this along y axis is called ordinate. So I am taking this p of x as y. Okay, suppose this p of x equals to y, and why I took this p of x equals to y? Because this p of x I wanted to represent it by y axis. Okay, so now you see now it become a linear equation in two variables. See, y equals to x plus 2, and I took this y axis as p of x. Okay, so now by seeing this I will make a solution box, and I will take maximum 3 pair of x and y. So you know this. Suppose this is x, this is y, just for identify, this is equation 1. Now see, when putting x equals to 1, x equals to 1, y will be 1 plus 2 equals to 3. Okay, one pair I got when x equals to 1, y equals to 3. Okay, same way putting x equals to 2, then I will get this is 2 plus 2 equals to 4. So when x equals to 2, y equals to 4. And last value, okay, I will take minimum value, so I can take x equals to 0 also, or you can take 3 also, whatever your wish. Okay, so I want to take small value, that's why I took here 0. So x equals to 0 plus 2 equals to 2. So when x equals to 0, y equals to 2. Okay, these are the solution sets of this polynomial. Okay, again I am saying that p of x is here y, so that I can plot p of x along this, and value of x on the x axis. Now see, 1 comma 3, x is 1, y3, and you know that when x is positive then it will go on this right side, and x is negative then left side, and y is positive means upward and y is negative means downward. Okay, it's very simple, you did already. So x is 1 and y equals to 3, 1 2 3. So roughly the point will be here. If it would graph, then you will get the exact figure, but then also you see here, so x equals to 2, y equals to 4. So x equals 1 2, y equals 4 means upward. Okay, 1 2 3 4, it will come almost here. Okay, now x equals to 0, y equals to 2. X equals 0, y equals to 2 means x equals 0 means it remains here. This is origin. Okay, coordinate of the origin is 0 comma 0, you know that. So it will come 0 comma 2 means it will come here. Okay, this. Now with the help of scale I am doing by the hand. Okay, so you will get this type of line. Okay, for identification I have given this A, B. Okay, so this is a straight line, is the graph of this polynomial. Clear? So actually this is a linear polynomial, and this you have to keep in your mind that for linear polynomial you will get always a straight line. Clear? So now you see here, from this graph, by studying this graph you can locate the zeros of these polynomials. Here zeros is what? X plus 2 equals 0, so x equals to minus 2 is the 0. But by seeing this graph, by studying this graph also we can find 0. So how to find 0? You know that 0 of the polynomial is the value. 0 of the polynomial is the value at which polynomials will be 0. So here you see x plus 2, it will cut it on the x-axis. So you see this graph cut it at x-axis at point P. Suppose I am giving this, what is this point? 2 comma 0. So you see here P of x is 0. P of x is 0 for one value of x, that is 2. Here abscissa is 2, ordinate is 0. So you know that zeros means the P of x polynomials will be 0 when the value of abscissa means value of x have some value. So what is the value of x? 2. Okay, for the value of x2 we are getting the value of P of x is 0. So therefore point P 2 comma 0, you know that this is on the point on the x-axis. So here y, it is P of x is equals to 0. So 0 of P of x is x equals to 2. So in this way also we can find the zeros of the polynomial. It is in linear case. Now I will explain you how to find the zeros of the polynomial or how to plot on the graph in quadratic polynomial. Okay.